morning, everyone. I'm Joseph Sirosh. I'm the CTO of AI in the worldwide commercial business at Microsoft. And I'm here to tell you about the exciting paradigm change that's happening in enterprise AI. And I call that the AI-oriented architecture for the enterprise. Now, many of you have heard of the service-oriented architecture from decades ago. What did the service-oriented architecture do to IT? Anybody? It's changed the way we developed and deployed applications. We created this concept of a service-oriented architecture as opposed to an object-oriented architecture in programming. And we encapsulated functionality in services. And then we had services communicate with each other and collectively form the architecture for the enterprise. So that was actually a revolution in how you scale up IT. Well, today, there is a new revolution. It's not quite like service-oriented architecture, but it is an AI-oriented architecture, where a lot of functions, instead of being programmed, are being learned using AI, and we are developing capabilities and applications, some of which are programmed, like in the traditional sense, some of which it is learned from data, and we are making these things work together. And there is a unique architecture that comes in play when you go build such capability. And that's what I really want to cover in this presentation. And as I go through the presentation, I'm going to actually illustrate some of this in depth with two case studies from inside of Microsoft and show the AI-oriented architecture behind it. And hopefully you will get an appreciation for how these things come together. There's some of the things I show may be complex, but you will now find simpler instantiations of it in other cases. So let's dive into it. So the future of software itself is a combination of traditional programming logic, and artificial intelligence. They come together. And let me explain that with a simple diagram. This is traditional software. It takes input data and program logic. Now, after all, program logic is also data, right? It's a set of instructions in a file. It takes all of that, goes to a compute, and then you get outputs. And that's a programming-oriented application architecture. So what happens when you have an AI-oriented application architecture? Now, you still have the diagram that I just showed. There's input, there's program logic, there's compute, there's output. But there's one more thing, one more piece of data, and that's models. Predictive models built for specific functions. And where do those models come from? That comes from another workflow. There's a learning phase. So when you develop models, what do you have? You have input data, expected outputs, the kind of results you want, right? So you provide those two things. There is an AI algorithm that then learns from that data. So input samples and expected outputs learns from examples, and then creates models as an output. Now, the models are predictive. And for example, let's take recommendations. Recommending new products for you to buy. Well, there's lots of historic examples where people have come to the websites or something and bought lots of products, and they know what products were bought together. That's the input data samples, and the expected outputs are what people actually bought, right? Which of the recommendations were people buying. So you know that, and then from which you learn a model, and then you have that model as going into the production phase. So this is the AI-oriented architecture, AI-oriented application architecture. Okay. So let's compare traditional software development with AI development. You'll see immediately some differences. In the traditional software development, you had data schemas and programs. But in AI development, you have to do a lot of data curation and labeling because you have to set up the teaching environment for AI. You got to learn the model. So you got to do a lot of nice curation of the data and give the teaching signals. So then in software development, you had functions and code. The equivalent in AI is machine learning models. So functions take an input, produce an output. In the machine learning case, the model takes an input, produces a predictive output. When you're debugging traditional software, you attach a debugger to a process, right? And then you go step through the code. Well, how do you debug AI? It's not quite like that. You do experimentation, and you feed it new inputs, see what output it produces, you test it in flight. So you actually do A/B testing. You run a bunch of experiments to see if it is producing the kind of output you want. You quantify that, and that's how you do it. And then in traditional applications with software, you use telemetry from the application, especially modern SaaS applications, to inform how the software is behaving. You're looking at metrics of various types. Well, in the case of AI applications, you're going to use that telemetry not just to inform, but to actually drive learning. That's a feedback loop from which you can actually learn, and you can continuously improve. So these are like 4 examples, 4 things that differ between the two. And there are, of course, more examples. Now let's go quickly to a couple of examples. One of the biggest transformations AI is bringing today is in natural user interfaces. The modern day user interfaces, voice computing, or handwriting recognition, or even neural interfaces that are being built now, those things really wouldn't exist without AI. AI is used to recognize the signals in very, very precise ways. So AI enables natural user interfaces. The biggest revolution in human-computer interaction that's happening today as we speak, and in the next few years, is being driven by AI. And the thing is, it's very powerful. Bill Gates recognized that in 2011. He said, with natural user interfaces, computing devices will adapt to our needs and preferences for the very first time. I mean, until now, we had to really learn computers and how to type and how to interact with them, how to move a mouse, how to go click on GUIs and all of that. Now they will start adapting to us. And humans will begin to use technology in whatever way is most comfortable and natural for us. And that's enabled by computers learning as opposed to us humans learning. And that's very powerful. Okay, so let me show you an example of one of those natural user interfaces. One of the little-known things these days is the power of handwriting or digital inking. So these are all things that are written by people, right? Try and type this. Try and enter this kind of information. The ink gives you expressiveness you can never achieve today without it with a keyboard. Incredibly powerful, whether it be drawing on a map or drawing pictures or expressing mathematical equations. How would you change this? How would you create natural user interfaces that allow this freedom of expression? Again, here's where AI comes in. The best way to see this is with a demo. We have already started our journey bringing that AI for natural user interfaces in PowerPoint and Word. And to show this to you in action, let me invite Robert Hauser, who is actually a principal SDE in the AI inking team at Microsoft. Robert, take it away.
Thanks, Joseph. So I'm going to show you a few demos today. And we're going to start here with a couple of real-world apps that you all have undoubtedly seen. We have Word and we have PowerPoint. And here I have Word running on a PC. And what I want to show you is some of the things that ink allows you to do. And really, we have 2 different paradigms. You can look at it in terms of gestures, and you can look at it in terms of recognition. And here, we're actually using gestures to do natural things with our documents. So say I have a doc that I've been putting together. I want to do a few edits on this thing. So we have this new ink editor, which I'll click on right here. And it allows you to do things like strike out some text. So magically goes away. I can do things like select, just naturally make a selection here. I can make this bold, increase the font, all sort of controls available to me here. I can also do things like, hey, I need to highlight some text because this is super important. So I can go along here, make a little highlight. And, let's just say I'm really not happy with all this. I'm just going to scratch it all out and start all over again. So that's a quick example of what we can do in Word. And I'm going to switch over here real quick. Actually, wait a second. Let me get this ready for you. I'll switch over to an iPad real quick and show you what we've been up to with PowerPoint. Oh, I hit the wrong button. Oh, okay. I got to rate this time. I do not want to rate this right now. So here I have my PowerPoint slide deck that I've been working on. And we have a draw tab here. And you actually notice that my pins actually followed me over here to the iPad. And I want to make a few edits to this. So I have my pen available to me right now, and I can do things like right here in the box, and I can select ink to text. I can select this, and a little sloppy on the handwriting there. Oh my goodness. That's always how it goes, right? So say I've actually done a little bit of inking already, and I want to go ahead and convert this. So I can go in here and I can select this guy. It'll select, I selected some of the ink there, and it automatically converts that over to text. And let's just say I want to make this a little bit more uniform and fit along with the rest of the presentation, and I can select the ink that represents the rectangles, and it switches all over to rectangles. So that's just a couple quick demos of what we can do today with ink analysis. And with that, I'll hand it back to Joseph.
Yeah. Well, that was AI. That's why it's not meant to be terrifying, but powerful. Great. So again, look at what it takes to build this. So this is handwriting samples and pictures that the team had to collect. Huge amounts of data. They used vendors and others. Then you see the boxes around them. They used vendors to actually label the data, to extract the key pieces to learn from. So first step is collect vast amounts of data like this, create the teaching signals so you can actually apply algorithms to learn from it. So then they had a number of machine learning models. Now, world is actually rich with choices. And for different types of tasks, you need to choose different types of models. So for ink classification, you would use one type. For layout analysis, you might use something like LSTMs, which is called long short-term memory, or hidden Markov models. I mean, sometimes sequence information is very important because the way you write, there's a certain sequence that you're following, and that needs to be captured properly for handwriting. And so you bring in the right kind of models for that. For shape recognition, and then for handwriting recognition, you bring in a collection of different models. Now, you saw Robert actually do a bunch of inking, and for handwriting recognition, in that particular case, where you saw the wonderful in-terror design, we had a number of machine learning approaches behind that. So you bring that in. Now, but the thing is, you need not understand a lot of these things that deeply. At this point, I actually have a saying that, if you can do Indian cooking, you can actually do machine learning. The most important thing is whether you can follow a recipe or not. If you can follow a recipe, if you can collect the data, curate the labels, and then you spend enough time just learning how some of these recipes, you can do a pretty good job. You don't have to have a PhD and develop your own algorithms. There's a significant collection available. Okay, so now let me actually take you to one more thing. So we showed you the models being built, and it's now built into PowerPoint. But what if we could take all of that power of understanding ink and handwriting and make that into an API on the cloud? What if we could just give it to all of you as software developers, a powerful API on the cloud, and it can take ink data and do all of that magic that you just saw in PowerPoint. And you can call it from any application, any software application, any device that is touch-enabled. To show you that demo, let me again have Robert take it away.
Thanks, Joseph. So moving back to our iPad app here. So we've developed a web app to actually show off that we're actually powered by a cloud service. And so this is just a simple progressive web app here. And what I can do is I can ink right in this canvas. And I'm going to send the request off to my service. And you can see here we did a little analysis, gives you a time. And we can do things with the response that comes back. Let me do this one more time, just to make sure I'm showing off what I want to show off. Okay, so here we have some information that came back, and I won't go into a lot of detail because there's a lot of numbers and letters there, but you can see things like we recognize there's a triangle here, and there's bounding rectangles and things like that, and it gives you rich information about what was inked and how we understood it using our AI. And what you can do with this, you can do powerful things, like I can beautify those shapes And your app can do all kinds of different things with that shape information that comes back. In addition, we support things like text input as well. So I'm going to load up a little bit of text that I inked before. And so this is ink as well. I'll send that off to the service real quick. I will not show you the results, just to keep this quick. But what you can tell is we actually were able to take that ink and understand that it actually has words in there, bread, butter, and jelly in this case, as well as alternates that the language models also think could be possible matches for what we found. In addition, we also get layout information. So we actually have to understand things like these are paragraphs and lines and bulleted lists and things like that. And so we can actually tell you what the bounding boxes look like. And when you have bounding box information, you can actually do things like, my list is not really that great here. I could clean this up a little bit, and actually I can tell the app to go ahead and align that over there to the left. So you can manipulate the ink strokes just because they have some meaning behind them, and we know what they actually are and what the user intended. And so you can increase the size of those strokes, all kinds of different things like that. And the last thing I'm going to show you is what's perhaps most powerful for the enterprise is because we do understand what the ink is, we can do things like actually search this text, right? So here I'm going to search for the word ink, and I'm going to go ahead and hit find. And we're actually able to find the set of strokes that represented that word. So behind the scenes, you can not only store the ink as ink, you can actually keep the textual meaning as well, and so you can search and index that at a later time, enabling all kinds of powerful capabilities for like field workers and such that might be using Pin today or in the future. So I'm going to switch back here real quick. Thank you. So with that in mind, I want to touch a little bit on what Joseph was talking about. It's our AI-oriented architecture. And ink has been around for a long time. Actually, we've been around for almost 20 years. Tablet PC days, and we've come a long way. And it's been a very organic process for us to build the machine learning that you just witnessed here today. And so this is a rough idea of what we do. A lot of this has roots in pre-cloud era, so we actually still do some of this online and offline now. But everything starts with gathering up samples. It is very, very difficult to gather good quality data, but it's something we work hard at and we're able to get over time, and we do that through a series of vendors and crowdsourcing, things like that. That data all has to be cleaned up and labeled, and we gather lots of statistics on it because we need to know what's working and what isn't working. And then we can move that into a pipeline, right? So we do training with GPU clusters and different technologies. We run through a continuous loop of trying to determine whether our machine learning is actually doing a good job, and toss out models and iterate again, make slight tweaks, and make sure our accuracy and performance is all good. And we do that on a regular basis since we do ship regularly. And I'm not going to even try to say that word right now, but basically moving this out into deployment, we move out into the cloud, which is basically the API I just showed you, and our traditional Windows APIs. So in recap, our mission really is to give you guys the tools that you need to create expressive and intuitive and now intelligent ink apps. We're looking to build faster and more frequent updates, which is why we're moving things into the cloud, to give you guys the most consistent experience and bring in bigger and better language models that can produce more powerful results, and also give that to all your different devices. So with that, I want to hand it back over to Joseph. And while he's coming up, if you want to come see more, Thursday we have a quick talk, or we have a breakout session. 2299 is the session number. So.
Great. Give a big hand to Robert, please. Thank you very much. So here's one other takeaway I want you to have. This is a journey that we are taking you all on from Microsoft, which is we build these sophisticated capabilities, incredibly sophisticated capabilities for inking, for example, in Windows, and it's incorporated into PowerPoint. And then we take that next step of encapsulating these as cloud APIs in Azure and bringing them out to all the developers so that all that effort, the incredible science that went in over a decade and over a decade, plus the machine learning models, plus the work they did with vendors to build that data labels and teach this and test it and all of that now comes to you as an API, and you can now start calling it from like a web app on iPad, which is what Robert just showed. And you can, as a developer, start using it in your software application to make your software application intelligent. That's the journey we are taking you all on. So in Satya's keynote in the morning, you saw speech, you saw language and translate and so on. We are bringing all of these sophisticated AI capabilities, which are not just algorithms anymore, right? It is decades of work by experts, but it's now coming to you as a simple API. So every enterprise of the future will need an AI-oriented architecture. And you're going to build an AI-oriented architecture. And what are you going to use it for? You're going to use it to empower employees. You're going to engage customers in incredibly smart ways. You're going to optimize operations in important ways, and then transform the nature of products itself. The product itself is going to be very different because it has an inking capability and a natural user interface or other smarts around it. So let's take some examples. For example, you will see today a demo of Cora, a sales assistant that we have deployed internally to empower our very large sales force with AI so they can be far more effective. ASOS is one of our customers, is a fashion retailer in the UK. They have built a recommendation system. So they deliver 13 million personalized experiences with 33 orders per second. That's recommendations and personalization. Imagine a fashion retailer doing the personalization. Then there's Kensai, a startup that is doing an AI-oriented architecture for healthcare to optimize operations of hospitals so that operations in hospitals can be as efficient as possible, meaning whether it be staffing management or bed management or emergency rooms or all of that, or even predicting chronic diseases. And then QuarterSpot, they've really transformed their product with machine learning and AI. So they've got 85% savings in risk calculation and underwriting costs using AI and machine learning models, and 50% lower loan defaults because they have used the power of machine learning and AI. So let's see some of the components that go into it. So on Azure now, we're providing an incredibly rich variety of components for you to build AI architectures with. Now, you don't have to use every one of these, of course, but you have a great selection available because many architectures are not the same. They're different. So you've got to choose the right ones. So there are sophisticated pre-trained models for computer vision, for speech, for language, for search. These are all APIs. There are popular frameworks that are available in open source now that you can run extremely efficiently in the cloud, whether it be PyTorch, TensorFlow, Keras, or Onyx. There are lots of productive options to develop these machine learning models. You can use Azure Databricks, which is Spark as a service, Azure Machine Learning VMs, bot service. And behind all of that is extremely powerful infrastructure, whether it be CPUs or GPUs or AI-specific infrastructure like FPGAs, which accelerate AI models dramatically and give you incredible price performance. So that's available now. And then deployment options. We allow you to actually even take models out as containers and deploy them on premises or on an IoT edge or, of course, in cloud VMs, in close to your application. So all of these choices are available to you, and you will see increasing amount of choice as you go forward. And Microsoft now is taking all of these capabilities and putting that into every one of its software. Every software at Microsoft will have an AI-oriented architecture. So let's now see more examples. An AI-oriented architecture to empower employees. So here are three. For example, there is Telefonica and now Vodafone. They have voice-enabled bots that can help customers find the products they want. In the middle is Flow, Progressive Insurance's bot. In November of last year, it sold the first auto insurance policy entirely over a bot on Facebook Messenger. On the right is Publicis and Microsoft announcing a bot called Marcel for use by the 80,000 employees or so inside of Publicis. They have 200 subsidiaries, and their employees are using this very powerful bot to come together, collaborate, and produce work. And now let me actually talk about our own sales assistant, what we have deployed inside Microsoft. So this is Quora. How many of you were in Satya's keynote? There was a brief mention of Quora and interacting with Quora over Cortana. But what it allows you as sales assistant is to take away the heavy lifting, the drudgery that a sales assistant has to go through to find the information he needs or she needs, and to interact with other peers and follow leads and so on. There's an enormous amount of work involved. The assistant makes that simpler. So here are examples of the kind of problems you're solving. A typical seller says, hey, today we can't do much strategic thinking because our jobs are so fast-paced. We spend a lot of time on operational issues, finding people, assembling data, and what I want to focus is on selling, strategy, and customer satisfaction. How many of you feel that way? I feel that way very often because a lot of my time is really spent collecting and curating data. At least half of the time I work as a data analyst, and the other half I try to be a sales professional. What if a bot, an intelligent bot, could simplify all of that? Here's a day in the life of a seller, right? Analyze gap to quota attainment. Look for news. Review customer account plan, but identify the right people. Identify right internal, external contacts. Prep for a customer meeting. Update pipeline. Prep for a manager meeting. And in the process, imagine how many tools that salesperson is going to. He's sitting in front of so many screens and context switching all the time and searching. And that's actually very difficult. So the thing is, how can a bot now come together, get the right recommendations at the right place, with the right content, to have the right conversations with the right people? That's ambition. That's what we are putting in front of AI to solve as a challenge. So here's what we are building. And we have built a lot of it, and there's lots more to come. So guided engagement, from left bottom going anti-clockwise, guided engagement, guided selling, a personalized user experience, looking at customer success, productivity, competitive intelligence, referential intelligence, relationship intelligence. All of those are being empowered by bots. And by the way, we have a lot of machine learning models internally, which we are integrating behind this bot. So for example, quota setting. Let me tell you about this one. Look, we have tens of thousands of sales folks. They get a quota set for sales every year at the beginning of the year. Typically, in the vast majority of organizations, how is this quota set? It's set by people munching data on Excel spreadsheets. And it's highly variable. There are thousands of managers in Microsoft, Salesforce managers, who are actually setting the quota. Highly variable, not always objective. Well, how do you solve that problem? We took data from multiple years. We looked at all the context of the data, and we built a machine learning model to predict the quota attainment, actual quota attainment of a seller using all of the data available to us. And we found that it could actually be really predictive. Could be, it had an 8% error rate. And then we put that in production for a year and tested it. And we gave managers the right to override it. And it turned out a lot of managers didn't override it. And so we developed confidence that the model is actually setting things, predicting things well. And then this year when we rolled it out, at the very beginning of the year, every salesperson could get a quota set by the machine learning system that was data-driven, that was objective, compared to, it took 3 months in previous years. Like the first quarter of the year was gone because there was really no quota set for the seller. Now the quota is set at the beginning of the year. Big transformation. This is the kind of transformation that you do with AI. And then there are models for lead scoring and churn prediction and automated and customized offers. So we are increasingly building models for every activity in a seller's life cycle. It's a complex diagram, and I'm not going to go through all of these. But these are examples of the things we are adding in. Lead scoring and routing. A peer recommender for peer sales, content graph that helps you bring in all the information and research, a slip deal predictor, so you can get early warning about these things, upsell and cross-sell models, so you know what else to sell to the customer, churn prediction, and forecasting of what might actually be the quota attainment, quota setting, and so on. So, and by the way, this is a journey. The thing I want you to take away is when you put an AI-oriented architecture in place, you are taking yourself on a journey of continuous improvement, learning from data, continuously launching new capabilities, and improving year after year in a very scientific way with metrics. So now, to show you the demo of the intelligent sales bot, let me invite Vandana.
Thanks, Joseph. Hello, everyone. This is something which we are calling it as Cora. As Joseph introduced, we are trying to get to a sales assistant where we can get the right context and the right information and a recommendation to a seller at the right time. Most of the time, they're trying to find the information. They remember there was an email that came, the notification that came, but they may not know exactly where it was. So this is our attempt to get it to the right person at the right time and save them some time and make them that much more efficient and effective. Cora is also enabled on my phone, so I can actually take it wherever I need to take it to. And it is voice enabled, so I can try and talk to it most of the times. And it gives me notifications at the right time, and they are proactive notifications. So let's take a look. I'm a salesperson. I really care for my quota. I sit in global sales and marketing organization. It has given me a notification that my deal is about to slip. So if we can get the voice.
Your opportunity with Kintosa due in 7 days has 74% chance to slip in the current quarter. Click on In-Class Experts to maximize the impact of this deal.
So as Joseph had mentioned, this is not just a notification that has come. It's come in as a recommendation. And to a seller who's not usually a data analyst or a data science genius, we do not want them to be dumped with a lot of information to go and process it. So what we are trying to give it to them is in a format where they can use it right away in a single pane of glass. And when it's giving me a particular recommendation, it's not just saying this particular opportunity is about to slip, which is, by the way, the slip deal predictor model, which is based on deep neural networks that we have built. And we have tested it over multiple quarters, and it's pretty accurate in predicting accurately across all the geographies, each of our opportunities, whether it will close in a particular quarter or not. It's also telling me how I can possibly go and close it because it's about to have a risk. So I press on In-Class Experts.
I found 3 in-class experts for your Northwind insurance building deal. Click on Schedule to book a meeting.
So it's working as an assistant, which has access to my Outlook, so it can see as much information about my calendar and the other person's calendar as the other person, as I would have. So I say, OK, go ahead, schedule.
All right, I found these upcoming meetings. Which one would you like to schedule? Great. I've scheduled to discuss Northwind insurance building deal for September 26, 3:30 p.m.
And now I need some material.
Here's top 10 ranked resources I found for you on Dynamics Pitch Decks.
So this is the content graph that Joseph was referring to. This is going through 30 different sources in the company that we have completed the tagging for. These are different internal and external Microsoft resources that we expect our sellers to have access to. So it is giving me, at a particular point in time, a direct access to a particular content that I should be using in that conversation. And it is available to me as a PowerPoint, which I can pick, edit, update, and use and send it to a customer directly. Or if I need to, I can project it on the screen. Or at least I have it right there versus spending 3 hours trying to find what I should be using. And many times where it helps in productivity is also because a lot of sellers across different geographies are trying to find the similar things. So we are trying to identify a pattern here to see what kind of material do people use when they're trying to find something, what is helpful and what is not. One more thing it's helping us do is make us more efficient. There are different studies which say that about 70% of the content generated in typical businesses never gets used for its intended purposes. Here we are trying to keep a tab on what's getting used, what's not getting used, so that then we can keep a measure on what we should not be generating in future and where we should be investing more to improve it further. So now Cora knows that I have attended the meeting because it has access to my calendar, and it sends me a notification.
Great to know you completed your customer meeting with Kintosa. Would you like to update forecast comments for this deal in MSX CRM?
So it is giving me an interface to talk to my CRM. MS6 is our deployment of Dynamics 365. What it is doing is the moment I step out from a customer meeting, giving me a nudge that would you like to log the meeting minutes. Those are called the golden 5 minutes when you step out from a meeting. Typically what a seller does is they would go at the Friday afternoon or a particular chosen time for their performance. They go in and update all the notes. At that point, you lose the essence of what needs to be captured in a particular node. And in machine learning terms, we really need to have the nuance of the language that gets captured, the words that were used in a particular meeting, because that defines how good the meeting was and what the next step should be. By just giving me an easy access to where I can update the meeting minutes, it is telling me to do it right now, and it's on a mobile device, but I can type out.
What comment would you like to add?
Okay.
Great. I've updated your comments. Click here to view your comments in CRM.
So if I want, I can go and check it, because at times the voice transcription may not work that very well. But for most part, it is done and it is updated in the CRM right there. So most of the sellers or most of the people are on mobile, so when they are walking out of the meeting, they can practically dictate it. Even before they reach their car, the CRM is updated instead of waiting for a month to update it before the manager meeting. So I just say, thank you, Kura. So this is how we are getting to a point where we are trying to enable our sellers in an AI-infused guided selling so that they can be as productive as the top 20% of the sellers in terms of efficiency and effectiveness. With that, back to you, Joseph. Thank you.
Great. So now let's talk about AI-oriented architectures to optimize operations. I'm going to take a healthcare example. We are all going to be affected in a positive way with the power of AI to optimize healthcare. We are all going to go into hospitals that will have AI behind the scenes to give you the very, very best care. Let's see some examples of that. Microsoft has a big investment now in healthcare and using data and AI to empower healthcare operations. So, for example, unlocking the potential of healthcare data with the cloud so that the data is portable, using what now is called a FHIR, FHIR standard for healthcare data interchange. Empowering people on the front lines of healthcare with the right information and the right tools for them to be efficient. For then transforming healthcare with precision medicine, whether it be AI or genomics or immunogenetics, we have amazing capabilities that are being built. Let me take an example from a startup, a very fast-growing partner of ours called Kensai. Their mission at Kensai is to fight death with data science. It's a huge opportunity. And here's an example of what it is. It's a predictive system of intelligence built for healthcare. So it covers everything. So patients come in. There's machine learning that is and data that's being used for proactive wellness plan and engagement to keep you healthy. Real-time care management for on-demand care management services, including interfacing with Uber and Instacart. Utilization-driven contract management. And digital command centers for hospital operations. And I'll show you what those things mean. Here's an example in a hospital. Just take one portion of hospital operations. Patients arrive, and you've got to look at, for example, emergency department arrivals, acuity, and you have predictions. There's an interesting model there at the top called LWBS prediction. Let me tell you what that is. That will give you an example of what this is. LWBS stands for left without being seen. Lots of people with serious conditions get tired of sitting in a waiting room in the hospital, and they leave without being seen. Now, if only you can predict that somebody would leave without being seen, the hospital can actually prioritize those people, because if you don't take care of them, they might come back with a very serious emergency, and it might cost the hospital and the whole system a lot more. So they have built models that are actually very predictive. So you can identify people who might leave without being seen. and then bring them in and take care of them. And so on and so forth. You have the ability to put AI models in every part of the workflow in a hospital and optimize things. Again, lots of examples here, whether it be for variation analysis or care management, like disease progression. There are models now that can predict the risk of chronic heart failure with high accuracy. There's a metric called the area under the curve, AUC metric, which now with certain machine learning models can achieve about 85% AUC, which is very powerful. Then you can take, think about acute patient flow, like length of stay. Very important for hospitals to predict how long, and machine learning models being used to build that model. And machine learning models being used to build that model. And machine learning models being used to build that model. And machine learning models being used to build that model. And machine learning models being used to build that model. And machine learning models being used to build that model. And machine learning models being used to build that model. And machine learning models being used to build that model. And machine learning models being used to build that model. And machine learning models being used to build that model. And machine learning models being used to build that model. And machine learning models being used to build that model. And machine learning models being used to build that model. And machine learning models being used to build that model. And machine learning models being used to build that model. And machine learning models being used to build that model. And machine learning models being used to build that model. And machine learning models being used to build that model. And machine learning models being used to build that model. And machine learning models being used to build that model. And machine learning models being used to build that model. And machine learning models being used to build that model. And then they deploy it. They deploy it in a flow like this. This is an AI-oriented architecture for length of stay prediction. Data comes from EMR systems, electronic medical record. They ingest the data using services like Databricks. They train, they have what's called a feature store for computing various features of the data. They have model services which you can build models. They then deploy it using Azure Container Services, and then they integrate that back into an EMR system or into a dashboard, a Power BI dashboard, in which they can see how the systems are performing. So I wanted to now start wrapping up. Look, you've now seen AI-oriented architectures for a few use cases. You're now going to see such architectures become extremely common and be built with the cloud as a backend. Cloud and AI coming together is incredibly powerful because it puts in place an architecture for continuous improvement, learning, and microservices-based deployments that allow you to do continuous updates of machine learning models, which is actually very important. How do you actually, when you build a new machine learning model, what is the best way to put that into production? Ideal way would be wrap that up in a container, put that in as a web service API, compare that with existing process, and do an A/B testing and flighting, and see if the new model is actually working well, and then put that back into production. All of those kinds of capabilities are enabled by the power of the cloud. So here's why you should build your AI-oriented architecture on Azure. First, it comes with the broadest set of pre-built AI capabilities, whether it be speech, language, or ink, and many more to come. You should expect thousands of APIs on the cloud for AI that developers can easily integrate. The second thing we have a big commitment to is that these are going to be customizable. Auto machine learning, if you want to call it, auto ML. Speech recognition, for example, you can customize it to your voice with your language models. A translation API we have, you can actually even build a whole new translator if you bring pairs, language pairs, like you bring data in, say, English and Chinese, enough data, you can actually have the system learn a translator for those pair of languages. In fact, people have actually built those. There's some of the machine learning, some of the translators for rare languages like Hmong, etc., were actually built by our customers by bringing their own data, and they built using our API. Then you'll see that we have the most advanced conversational AI with bot framework, the Azure bot service, the LUIS language understanding intelligence service, and so on. We have the components required for you to set up those kind of conversational bots like you saw with Cora. Very powerful. Then we also provide the differentiated support for AI at the edge, meaning run your AI locally at edge devices that are connected to the cloud. IoT Edge can now host containerized deployments of machine learning models. And we also bring unique AI hardware like FPGAs. Now you can use field programmable gate arrays with Azure Machine Learning to have extremely low latency vision image models, for example. Then finally, we are the strongest enterprise cloud for data and AI. Integration into your enterprise environment in that hybrid model of both on-premises and the cloud. Nobody else besides Azure really enables you to do it as easily. Very powerful. So here's now how to start the AI journey. Well, look, most people start the journey into data with business intelligence, BI, collecting, curating the data, creating metrics. And for that, you have Power BI. And you have Power Apps plus Flow. You have Azure Data Service of various types and SQL Server. But these are available as managed services on the cloud. Then when you step up to the next level, you go to software applications, SaaS with AI. And there you have Dynamics 365 for AI for sales. Some of the capabilities that you saw in the Cora bot is now available with Dynamics 365. You have Dynamics 365 AI for market insights, AI for customer service, and even for workplace analytics. So that's the next step up in sophistication. Then you go further up to AI maturity. You can integrate these APIs that I talked about, whether it be an AI API for ink or vision, custom vision, face recognition, language translation. There's about 30 APIs like that. And then there is Azure Cognitive Search, which is very powerful for knowledge management. And then when you get more sophisticated technical folks in your organization who have data science capabilities, then you go to custom AI, where you use sophisticated programming environments for AI like Azure Databricks or Azure Machine Learning and open frameworks, and where some types of the Azure Cognitive Services, and you custom build your own models with your own data, right? That's the journey of AI maturity. So the additional resources for you, Azure.com/AI has a tremendous number of resources. We have an AI school.microsoft.com and AIlab.microsoft.com. So go here, start your journey into the AI-oriented architecture today. Thank you.